Ladies and gentlemen, Kalispera. So we're the lucky winner of the post-lunch presentation. And luckily we have a very interesting topic at hand, ensuring that everyone stays sharp and not the least awake during this session. I must mention Tom Evensen. I'm sales manager at an entity within the paint manufacturer Jotun called Hull Performance Solutions. And this will be a joint presentation where I will be accompanied by my colleague, Mr. Manolis Levantis, our Analyst Manager. So, why are we as paint makers represented here today? One of the recurring challenges the industry faces is the relentless focus on efficiency, cost, and environmental issues. It goes without saying that all of these are somehow interlinked, and Hull and Propeller Performance stands out as one of the lower hanging fruits as seen from our point of view. The accumulation of fouling is a vessel's operator's true nightmare. It's a true killer for operational efficiency and could again lead to potentially substantial overconsumption of fuel, and even low levels of accumulation of slime can have a significant impact on the vessel's efficiency. This chart is displaying the purchasing behavior of a major share of the global merchant fleet between 2012 and 2018. The data sample is the accumulative result of more than 40,000 dry dockings, equal to 1.5 billion deadweight tons, and this is across all vessel types and across all major marine coating suppliers. And we noticed that from 2012 to 2014, we experienced a shift in purchasing behavior with a larger number of customers having increased focus on what we categorize as well-performing products. So that would be this period. But since 2014, very little has changed in terms of purchasing behavior. Now, you as representatives of the shipping industry, you're virtually being bombarded with all sorts of performance-enhancing measures and technologies. And in Jotun, we focus on the hull performance part, which represents a larger improvement potential than most would think. Numerous studies and reports have disclosed the vast importance of good hull and propeller performance. So why is it that this very important area is being given such little focus? And speaking to our close customers and partners, we believe that one of the root causes might be that coatings are categorized as consumables and not regarded as permanent investments. Now, whatever offer comes on your desk, you need to ask yourself 3 questions. What's the investment being asked for? Secondly, what's the return of investment? And thirdly, how is this potential saving measured and documented? Through the next couple of slides, my colleague and myself will take you through the path to achieve maximum hull efficiency as seen from a paint maker's perspective. It all starts with proper surface preparations. Having worked through a great number of reference cases, we have disclosed that for touch-ups, there's a saving potential of between 3 to 7% in speed gain. For full blasts, it's in the range of 5 to 17%. The next would be to invest in a proper performing and documented coating system. Most anti-fouling, they perform quite well for 2 to 3 years and then experience a quite steep drop in performance. Investing in high-end anti-fouling coatings, you would be able to lift the performance in a significant level and thereby experience a much more stable performing than as we see with market average performing technologies. The next step would be the highest possible level of application excellence, Regardless of technology, cheap or expensive, it's still a semi-finished product, wet paint in a bucket, which has to be applied in a proper way under challenging conditions. Moving from good applications to a worst-case application can have a significant impact on the overall performance of a vessel. The next step is moving into as optimized specifications as possible. And Jotun has for quite some time been using high-resolution AIS data to analyze the historical trade of vessels and expected future trade in order to calculate the effective operational parameters. And in a number of cases, we have seen that the parameters being used are quite far off from what we see in these scatter plots, which will be the most frequent values when it comes to temperature and speed of these vessels. I'm going to leave the floor to my colleague, Mr. Manolis Levantis. Thank you so much.
Good afternoon. My name is Manolis Levantis, and I work for Jotun as an Analyst Manager in hull performance solutions. And I have the honor to lead the analytical team in Jotun globally. And why we are here, we the analysts, is because we think that a more analytical approach should be followed the moment the vessel leaves the dock. Starting point, performance monitoring. I'm sure everybody here, all operators, are doing some kind of performance monitoring. But it's no secret that we have been strong supporters of the ISO 19030 methodology. We believe it is a good methodology, not perfect, but a good methodology in order to measure hull and propeller performance. And most importantly, it is a transparent methodology and all relevant stakeholders may agree on. Very quickly, for performance indicators of the ISO 19030, dry docking performance is a KPI where we can measure initial coating performance and the effect of surface preparation and application excellence, as Mr. Evensen mentioned to you earlier. In-service performance is a KPI where we can measure the hull and propeller performance over the vessel's dry dock cycle, 3 or 5 years, and this includes any maintenance that might have taken place during that period. Maintenance trigger is a very interesting KPI from an operator's point of view, because we can check when is the right time to do a maintenance. And this maintenance can be propeller cleaning, hull cleaning, or even a dry dock. And when we do this maintenance, maintenance effect is a KPI to measure the effect of that maintenance. But now, so performance monitoring is the starting point, but we also now have access to other data sources. And we can use hindcast data in order to do statistical analysis on oceanographic parameters and identify the conditions that the vessel has been exposed to over time. So we have access to sea surface temperature, we have access to concentration of chlorophyll and other oceanographic parameters which can help us do our statistical analysis. And we can use the outcomes of this analysis in order to identify low-risk idling positions. For those who don't know, the most challenging condition for a vessel hull is when the vessel is idling. So we can use current data, historical data, and identify where would be a right place to position the vessel in order to stay for some extended period of time. We can also use this data to create probabilistic models. And these probabilistic models can give us outcomes such as this. So we can rate vessels or trade based on fouling pressure. What's the benefit of that is that operators can focus more on the red or the yellow vessels. Like I said before, this is a probabilistic model. It doesn't necessarily mean that green the vessel is going to be clean. It just means that the probability of this vessel's hull to be clean is going to be higher. Finally, all this data can also be used for proactive in-service maintenance regime. What we see nowadays is that inspection and maintenance schemes are not rigid enough to avoid hull deterioration. Some operators start to do inspections after the third or the fourth year, whereas other operators, they do by default 3 or 4 times per year. So by having well-timed and analytical-driven inspections and maintenance, we can improve efficiency substantially. We can have more optimized specifications and by that reduce the costs. To summarize, in order to maximize, for operators to maximize hull efficiency, investment in premium coatings is the starting point. This will help us raise the overall performance level at a higher level. Proper surface preparation and application of excellence is something that operators should focus. We need access to right data in order to have correct specifications, to do proper performance monitoring based on ISO 19030 methodology, statistical analysis on oceanographic parameters, identify less risky areas to idle, less risky trades or vessels, and finally, proactive in-service maintenance regime. Thank you very much.